usually constitutes of statistics and kinematics. Question 7 is statistics. So let's look at question 7 right here. Looking at question 7, it says a survey is carried out in a town and it revealed that 25% of the household surveyed owned a laptop and 70% owned a desktop. In addition, it was found that 12% owned both a laptop and a desktop. If a sample of the household from the town is selected at random, determine the proportion that neither owned a laptop nor a desktop. All right. Now this question, you can answer it numerous amount of ways. You can use a Venn diagram. You can use anything you want. Let's say you wanted to use a Venn diagram. All right. This is just, I'm showing you how maths is connected. All right. The universal set just represents 100%. All right. Universal set in this case represents 100%. All right. I told us that you have a certain amount that own laptop computer I'll use for L, and they said a certain amount use desktop computer, and desktop computer I will use as D. So this is desktop computer. They told us how much own laptop. 25% own laptop. So if 25% own laptop, all right, and how much own the both? 12% own both. All right, so this is 12. So if this is 12, then in here where it's laptop only is 13, because we need 13 plus 12 to give us the 25. Then out here now is what? Right here, so now is 70% on desktop computers, but 70 minus 12 is 58. So desktop only is 58. So here what this question asks us now. It said, if a sample of household from the town is selected, determine the proportion that neither owned a laptop or a desktop. So out here, I'm going to call X. Now, what I know is that from my Venn diagram, 13 plus my 12 plus my 58 plus my X is equal to 100%. All right, that's what I know from my Venn diagram. All right, now 58 and 12 is 70 plus 13. 70 plus 13. Let me check that with my calculator. I'm not as sharp as one time. That's 83. All of this is 83. And so 83 plus X is equal to 100%. And so what does that tell me? That tells me that 17% is X. All right, that tells me 17% is X. So this is telling me that 17% neither owns a desktop or a laptop computer. That's what that is telling me. So this is using a Venn diagram. I'm just getting creative to do this question. Nice and easy. That's part A. Part B says a bag contains 4 red marbles, 3 black. A bag contains 4 red marbles, 3 black marbles, and 3 blue marbles. 3 marbles are drawn at random without replacement. Find the probability that all drawn are the same color. So find the probability that once you draw the same color. Now, in order to draw the same color, there are 3 ways this can happen. All right. So the probability of you drawing the same color means we're finding the probability that you draw red, then you draw red, then you draw red, plus the probability that you can draw black, then you draw black, then you draw black. All right, that's still drawing the same color, plus the probability of you can draw blue, then blue, then blue. So if I let black B represent black, for blue, I'm gonna write BL. BL represents blue. You can draw blue, then blue, then blue. So let's work this out now. So this is going to be equal to the to draw red on the first one is going to be, you have 10 marbles. How much red did it? 4 red. So there's a 4 out of 10 chance the first one going to be red. Times, when you take out 1 red, you're left back with 9 marble. And then 3 red in there. So the next red will be 3 out of 9. Times, when you take out that red now, you're going to be left back with 8 marbles. But how many red will be in there now? 2. So that's the probability of getting red, red, red. Plus the probability of getting black, black, black. You have 10 marbles and you take out a black. The chance is 3 out of 10 to get a black. Now after you take out that black, you're going to have 9 marbles left. And so if you take out another black marble, there's 2 more in there, so it's 2 out of 9. When you take out that black, there's going to be 8 marbles left, but only 1 in there that's black. So the chance of you getting the last black is 1 out of 8. Plus, it's going to be the same for the blue. 3 out of 10 times 2 out of 9 times 1 over 8. And this question is so easy. Soft with a capital, let me say it again, soft with a capital T. Too easy. So you work this out and you get 4 over 10 times 3 over 9 times 2 over 8. This is 1 over 30 plus, you can just work out everything in a calculator. 3 over 10 times 2 over 9 times 1 over 8. That's 1 over 120 plus 3 over 10 times 2 over 9 times 1 over 8, and that's also 1 over 120. That's equal to, let's work this out now. So 1 over 120 plus 1 over 120 plus 1 over 30, and that's just 1 over 20. So that's the chance of you getting the same color. So there's a very slim chance. There's actually a 5% chance of you getting the same color. So I wouldn't even dream of picking the same color 3 times. Now it says, find the probability that the marbles, that when you draw the 3, it contains exactly 1 red marble. So to find the probability of getting just 1 red marble, it means it doesn't matter about the other 2 colors. So you can get, there are many solutions. We just want 1 red. So there are 2 ways you can do it. So to find the probability of getting exactly 1 red is equal to, let me write it down, the probability of getting 1 red, that's going to be equal to 1 minus the probability of no red. That's the only way you can get it. So the probability of 1 minus no red will give you the probability of 1 red. This is one way you can do it. So let's find the probability of no red first. All right. So the probability of no red, this is one way. I'm just showing you one way. Another way you can do it is the probability of one red, just showing you the both methods. The probability of one red means that we can say it is the probability of getting, to get one red means you can get maybe a black and a black and then a red, all right? Or you can get the probability of a black and a blue. Let me use L for blue, black, then a blue, then the red. It doesn't matter, it's just one red there, plus the probability of getting a black, or the probability of getting a blue, and then a red, plus the probability of getting, you can get, so a blue, blue, black, black, and there's a chance of you getting a blue, then a black, then a red. That would be the probability of getting one red. All right, that's the probability of getting one red. You just want to know, say you get at least one red. All right, so anyway you want to work it out, which is 1 minus the probability of no red, or you can work it out as probability of one red is this. So let's do it both ways. All right, I'm going to start with the second one since it seems shorter. For the second one, which is a probability of one red, the second method is just the probability of, so the probability of one red, in this case, I'm just going to write 1R is equal to the probability of getting a black, then a red is 3 out of 10. Then when you take out that black, you get now times you have 2 black left out of 9 times the red now is, you have 8 marbles in there, and you have to take out one red. One red will be, let me see, one red, 4 red in there, so it's 4 out of 8 plus. And you do the same for these and these and these and these. All right, this method seems longer, but this is the principle. I'm just going to do the first one. 1 minus no red. It does seem shorter now. So the probability of no red means you draw absolutely no red at all. To draw no red at all, you can either draw black, then black, then black, or you can maybe draw black, then blue, then black, or you can draw black, then black, then blue, or you can draw black, then black, then black, or you can draw blue, then black, then blue, then black, or you can draw black, then black, then blue, or you can draw black, then blue, or you can draw blue, then black, then black. Let me see if I got all them. With the 3 blacks, yes. Then with 2 blacks, you can either draw black, black, blue, black, black, blue. And then you can draw blue, black, then blue, blue. Then you can draw blue, then black, black. Then you can draw blue, then black, then blue. Or you can draw blue, blue, blue. Or you can draw, let me see, or you can draw blue, black. Let me see. This match black, 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 blue, 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 black, 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 blue, blue, black, black, blue. We need blue, black, black, blue, black, 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 blue, black, blue, black, or black, blue, black, or blue, black, blue. These like one's missing. Is one missing? These are all where the possibilities with no red. We can draw black, 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 blue, blue, blue. We can draw black, blue, black, 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 blue, blue, black, blue, 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 black, black, blue, black, blue, and blue, blue, blue. So look at the two cases where we can draw straight blue or straight black. Or look at the possibilities and we can be drawing two blacks, that's these two. Look at the possibilities we can be drawing two blacks. Look at the possibilities we can be drawing two blue. Two blacks can be black, black, blue, blue, or blue, black, black. Here, here's another one. All right. So those are the three possibilities we can draw. Two black. We need the three possibilities so we can draw two blue now. So what are the three of them? We have can draw the black first, then blue, blue. Or we can draw the blue, then the black, then the blue. Or we can draw blue, blue, black. That's the one that is missing, blue, blue, black. Blue, blue, black. A new one was missing. So this would be no red. So let's work it out. So the probability of drawing black, black, black. We worked it out up here already. The probability of drawing black, 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 which was 1 over 120. Then the probability of drawing black, then blue, then black will be black, then blue, then black. It's 1 over, not 1. How many black is there? 3. So it's 3 over 10 times, drawing your blue now, you're going to have 3 over 9 times, drawing your next black now is, we take out one black already, so it's 2 over 8. Plus, drawing blue, then blue, drawing black, then blue is going to be 3 over 10, 2 over 9, then your blue is 3 over 8. And notice something. Notice that this and this is the same. Plus, draw blue, then draw black, then blue is 3 over 10 times, drawing blue now is 3 over 9 times, drawing the next blue is 2 over 8. All right. Without working out the rest, I can see where this is going. I can tell you that blue, black, black is going to be the same. 3 over 10 times 2 over 9 times 3 over 9. I can see it times 3 over 8. I can tell you already. Plus, this again is going to be 3 over 10 times 3 over 9 times 2 over 8. Plus, of course, your blue, 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 which you know is 1 over 120. Plus our blue, blue, black, which again is 3 over 10, 2 over 9, 3 over 8. We're going to work out all of this. That will give us the probability of getting no red. All right, so when I work it out, it's going to be 3 over 10 times 3 over 9 times 2 over 8. That is 1 over 140. This right here is 1 over 40. And look how many 1 over 40 we have. 1, 2, 3, 4, 5 of them. Is it 5? 1, 2, 3, 4, 5, 6 of them. So this just works out to be 1 over 120 plus 1 over 120 plus 6 over 40. 1 over 120 times 2 plus 6 over 40. And I'm getting 1 over 6. So that's the probability of getting no red, 1 over 6. So what does that mean? That means we're very likely to get a red. So the probability of one red is equal to 1 minus 1 over 6. And the chances of you getting a red is 5 over 6. So there's a very high possibility you will get a red. Very high possibility. There's a very high chance you'll get a red. So that's it. Probability of one red is 5 over 6. Nice and easy, soft. Now let's go to part C. Part C says the probability of hiring a taxi from garage A, B, or C is a half, 0.5, and 0.2. The probability that the taxi ordered will be late is 7%, and from B, 10%, and C is 20%. Use a tree diagram. Nice and easy. Tree diagrams are so easy. So first and foremost, recognize that you have 3 taxes. So that's where you start it with. You start with the 3 taxes then. So I just use this dot as a reference point. You have A, you have B, you have C. So taxi A, taxi B, taxi C. Chance of you using taxi A is 0.3. Chance of you using taxi B is 0.5. Chance of you using taxi C is, I think that's a 0.2. And then now it says it gives us the chance of each of them being late. All right, so I'm going to use black to extend the other line. It's either taxi A or show up on time. What can I use for on time? We can use L for late, and on time mean T, arriving on time. All right, T means on time. So it says the chances of A being late is 0.07. There's a 7% chance A will be late. So there's a 93% chance A will be early. I would want to go with taxi A. Taxi B, there's a 10% chance taxi B will be late. I don't like that service. All right, so on time and late, you're telling me that there's a 10% chance taxi B will be late, and this one is 0.9% chance it will be early. Then let's go way over to here with taxi C. Now, chance of taxi C being late will be 0.2. That's 20% chance taxi C is being late. That is very high. That's a very high chance. I wouldn't want to go with taxi C at all. This is a tree diagram. This is part CI. So we're done with tree diagram. Nice and easy. Let's hear what them have to say now. So they said now a garage is chosen at random. Determine the probability that the taxi will be late. So what's the chances of the taxi being late? So the chance of the taxi being late will be the chances of A being late plus the probability of B being late plus the probability of C being late. All right, so the probability of a taxi being late, I'm just going to write the probability of the taxi being late is going to be equal to chances of A being late. So the probability of A being late is going to be 0.3 times 0.7. 0.3 times 0.7, because that's the chance of A even getting picked, plus the probability of B actually being late, because B, there's a 50% chance B will come and a 10% chance B will be late. So the probability of B definitely being late is 0.5 times 0.1 plus, now C, now probability of C getting picked is 0.2, and then chances of C being late is 0.2. So I multiply those. That will give me the chance of this taxi being late. So the probability of the taxi being late will be 0.3 times 0.7 plus 0.5 times 0.1 plus 0.2 times 0.2. That's 0.3. So that means there's a 30% chance the taxi will go late. No matter which one you choose, overall there's a 30% chance of being late. It says find the probability that the taxi will come from garage C given that it is late. So this was the probability of L, all right? This was the probability of L. Now what they're asking for right now is the probability of, it says the taxi will come from garage C given that it is late. So they want the probability of C given L. Now the probability of C given L, now this is conditional probability, is the probability of C intersect L divided by the probability of L. So what that means is the probability of we choosing taxi C and it come late. The probability of choosing taxi C and it come late will be probability of choosing taxi C is 0.2 times the probability of it being late, which is also 0.2, and then we divide it by the probability of the taxi being late. Probability of the taxi being late was 0.3. So work that out. 0.2 times 0.2 divided by 0.3, and that works out to be 0.133. 0.13. Nice and easy, soft. And that's a chance of we choosing taxi C given that it's going to be late. This takes care of question 7. So this is question 7, the statistics question. Very easy. And so now, of course, it's time to go to kinematics. All right, so as we go to kinematics, which means motion in a straight line, let's look at what question 8 is saying. Question 8, it says, a car starting from rest at A moves along a straight line, reaching a velocity of 24 meters per second, and it has a constant acceleration of 6 meters per second, blah, blah, blah. The car maintains this constant speed for 5 seconds, and then it is brought to rest again. It says using the graph sheet provided, draw a velocity time graph to